We are the Group 3 of 12 St. James, and today we are going to present our research entitled Examining Cucurbita or Pumpkin Agricultural Waste as an Adsorbent of Mercury in Meycauayan, Marilao, and Bocaue rivers. To present the background of the study unto the theoretical framework, here is Desiree Tecson.
Mercury is a very toxic type of heavy metal, as it can cause diseases to humans. That is why the presence of heavy metal is one of the primarily concerned in the environment. One way of eliminating heavy metal is adsorption. Adsorption is environmental friendly, low cost, and easy to implement. And one of the examples of this is the Cucurbita agricultural waste, or simply pumpkin. It contains the carboxylic groups and lignocellulosic materials, essentially known to be one of the compositional characteristics of successful heavy metal adsorption. The rationale of this study is to examine if Cucurbita agricultural waste can be used as an adsorbent of mercury in the waters of Meycauayan, Marilao, and Bocaue rivers. The main problem of this study is, can Cucurbita agricultural waste be used as an adsorbent of mercury in Meycauayan, Marilao, and Bocaue rivers? Now let's go on to the specific problems. Specific problem number 1. How are the waters of Meycauayan, Marilao, and Bocaue rivers compared in terms of the physical properties, namely boiling point, pH level, and intensity? What are the properties of Cucurbita agricultural waste? Number 3. Is mercury present in the waters of Meycauayan, Marilao, and Bocaue rivers along MacArthur Highway? Number 4. Which river has the highest and lowest level of mercury? Number 5. Is there a significant difference of the levels of mercury found in the waters of Meycauayan, Marilao, and Bocaue rivers before exposure to Cucurbita agricultural waste? Number 6. What happens to the level of mercury after exposure to Cucurbita agricultural waste? Number 7. Is there a significant difference in the levels of mercury found in the water of Meycauayan, Marilao, and Bocaue rivers after exposure to Cucurbita agricultural waste? Number 8. How are the waters of Meycauayan, Marilao, and Bocaue rivers compared in terms of mercury level contamination? Number 9. Is the Cucurbita agricultural waste effective in absorbing of mercury found in the waters of Meycauayan, Marilao, and Bocaue rivers? Now let's go on to the theoretical framework. The Brenner-Emmett theory, or the Bath theory, portrays the physical properties of gas molecules from a solid surface. In relation to the study, this can be related to the process of adsorption occurs given the adsorptive properties. These properties involve the solution rate, catalytic activity, moisture retention, and shelf life, which are correlated to a material's surface tension. The density functional theory, studied by Koh and Honenberg in 1970, portrays that the density of an existing system determines the ground state properties of that specific system. In relation to the study, this will be conducting an analysis more on the percentage of the heavy metal that will be removed from the experimental concentration. The Langmuir adsorption isotherm theory by Langmuir in 1918 has a similarity to the Bath theory in terms of its adsorption and solid surfaces. This theory stated that the relationship formed between adsorption and pressure. The difference of the Langmuir adsorption isotherm theory from the Bath theory is that the absorption process occurs for monolayer. In relation to the study, that this provides that there are existing active sites from the location to be tested. This occurs in the process of atomic adsorption spectroscopy, where the chemical elements are emitted by adsorption through optical radiation, as it converts the free atoms of the heavy metal in its gaseous state. And this undertaking is known as atomization. Theory for X-ray and neutron scattering of lignocellulosic biomass characterization. The process of adsorption can also be related to the hydrolysis of lignocellulosic lignins and hemicellulosis, as it also connected to the protein binding. In relation to the study, X-ray and neutron scattering on lignocellulosic materials has helped in identifying how other agricultural wastes, such as banana peelings, can be used as an adsorption of various heavy metal from bodies of water. Now, to present the conceptual framework until the significance of the study, here is Sophia Joson.
The conceptual framework illustrates several contexts to be seen from the study we're in. There's input, process, and output. Input: amount of water samples to be collected, 500 milliliters. Amount of Cucurbita agricultural waste, 100 grams. Time of exposure, 8 hours. Process: research design through experimental design. Methodology: atomic absorption spectroscopy. Data gathering analysis, statistical treatment, descriptive and analytical. Output: effectiveness of Cucurbita agricultural waste as an adsorbent of heavy metals in Meycauayan, Marilao, and Bocaue rivers. The research hypothesis is divided into two. First, we have the null. There is no presence of mercury in the rivers of Meycauayan, Marilao, and Bocaue along MacArthur Highway. There is no significant difference on the mercury content of the rivers of Meycauayan, Marilao, and Bocaue before and after exposure to Cucurbita agricultural waste. The Cucurbita agricultural waste is not effective in absorbing the mercury found in the rivers of Meycauayan, Marilao, and Bocaue. Then, for the alternative, there is the presence of mercury in the rivers of Meycauayan, Marilao, and Bocaue along MacArthur Highway. There is a significant difference on the mercury content of the rivers of Meycauayan, Marilao, and Bocaue before and after exposure to Cucurbita agricultural waste. The Cucurbita agricultural waste is effective in absorbing the mercury found in the rivers of Meycauayan, Marilao, and Bocaue. For the definition of terms, first, we have agricultural waste, unwanted waste product as a result of agricultural activities. Operational, specific agricultural waste to be used is Cucurbita since its adsorptive property comes from the carbocyclic groups and lignocellulosic materials that it contains. Second, boiling point. Temperature at which the vapor pressure of a liquid equals the external pressure surrounding the liquid occurs at surface of liquid. Operational can be determined through distillation or flux and by using a Thiel tube, can be done by separating the components or substances from a liquid mixture by selective boiling and condensation. Third, Cucurbita. Generally considered as an agricultural waste and are extraordinarily rich sources of bioactive compounds. Operational, obtained by only using skin and a bit of the flesh, not including the entire flesh and seeds. Fourth, density. Mass per unit volume, measure of relative heaviness of object with constant volume would be greater if packed tightly. Operational. Take the mass and divide by volume, usually expressed in grams per cubic centimeter, can be measured using a hydrometer. Fifth, heavy metal. Metal is considered heavy metal when it causes harm to living organisms such as mercury, lead, and cadmium. Operational, the presence of heavy metals can be examined using the atomic absorption spectrophotometry. 6. Maximum contaminant level. Highest level of a contaminant that is allowed in drinking water based on cost-benefit analysis and is enforceable. Operational, measured when water enters a public water system's user's outlet and where water first enters a distribution system, when turbidity is a problem. Mercury has a maximum contaminant level of 0.002 milligrams per liter. 7. Maximum contaminant level goal. Level of contaminant in drinking water below which there is no known or expected risk to health, set at levels which water treatment systems cannot meet. Operational, established through a scientific process that only considers the health impacts of a contaminant in water. Maximum contaminant level goal of mercury is 0.002 milligrams per liter. 8. Mercury, naturally occurring metal that is present in several forms such as metallic, organic, and inorganic mercury. A naturally occurring element on Earth, and high levels of it are highly toxic to humans. Operational, mercury presence is determined through the process of atomic adsorption spectrophotometry. Lastly, pH level, measure of hydrogen ion concentration, a measure of the acidity or alkalinity of a solution. Solutions with a lower concentration of hydrogen ions have a higher pH or are basic, and those with a higher concentration are low pH or acidic, while 7 is neutral. Operational, can be measured through the pH meter, which measures the acidity and alkalinity of a fluid, comprised of a special measuring probe attached to an electronic meter that displays the decimal pH reading. Now let's go to the significance of the study. For the students, the research would provide awareness of heavy metal toxicity, specifically mercury and its effects in bodies of water, which leads to water pollution. This study provides an aid to the students and the future generations to be mindful of such actions causing contamination. For the community, the study may serve as a stepping stone to resolve the concern regarding water pollution in the community, especially to those people living near the rivers to be tested by the researchers. It may also be beneficial for them in having knowledge on the negative effects of mercury and other heavy metals present in Meycauayan, Marilao, and Bocaue rivers, and to gain insight on the different safety measures to be implemented to reduce these harmful effects. For the local and national government, what the study addresses may be used as a springboard by various local and national government agencies in the enforcement of laws regarding nationwide safety precautions for heavy metals and different programs to be administered to affected communities and work ethics to be given to industrial and commercial buildings with regards to their waste management. For the future researchers, the concepts to be presented may be used as reference data in conducting new researches or in testing the validity of other related findings. This study may also serve as their cross-reference, yielding an overview of how Cucurbita agricultural waste can be used as an adsorbent. Scope and delimitation of the study. Cucurbita agricultural waste was specifically chosen by the researchers since previous research has shown the effectivity of other locus adsorbents in the removal of heavy metals from bodies of water. This includes a success attributed to the presence of carbocyclic groups in banana peelings. In like manner, as mentioned by Harmon, Patrick, and Spittler, from an article, cucurbita or pumpkin could also be used in the removal of metal ions due to the presence of carbocyclic groups and lignocellulosic materials. In particular, pectin, a biopolymer that is known to be valuable in different fields, is what composes pumpkin. In a recent study of Souza et al., pectin was stated to be a polysaccharide effective in removing heavy metal ions from the body, thus lowers blood cholesterol level and stabilizes blood pressure. Additionally, the study concluded that Cucurbita muscata contains chain of pectin polysaccharide, effective for bioactive encapsulations and other solidification and adsorption processes. Additionally, this study was also conducted through the use of the skin or the outer part and a little portion of the inner flesh of the Cucurbita agricultural waste. And that is all for Chapter 1. Again, I am Sophia Joson, and to move forward with the Chapter 3 of the study, here is Christine de la Cruz to present.
The Chapter 3 contains, primarily, the methods and procedures that were used by the researchers for this study. Firstly, for this study, a true experimentation was conducted. The researchers personally gathered all the water samples from the rivers of Meycauayan, Marilao, and Bocaue. For the preparation of the cucurbita that was used by the researchers was obtained from the leftover found in the kitchen. Then, it was rinsed thoroughly and was cut into thin strips so that it can be easily baked. After this, the thin strips were placed in a tray and heated in the oven for about 3 hours at 100 degrees Celsius. After baking the strips of the cucurbita for 3 hours, the researchers had pulverized the strips, transferred it into a DIY tea bag that were made by the researchers using light towels, which has 100 grams of cucurbita powder each. For the water samples were personally gathered by the researchers in Meycauayan, Marilao, and Bocaue rivers. The water samples were placed in the water bottle as suggested by the laboratory where it was tested. For combining the water samples with cucurbita agricultural waste, the 500 ml of water sample was placed in a larger container. Then, the DIY tea bag that has 100 grams of pulverized cucurbita was placed inside and was exposed for 8 hours. The analysis of the samples. The researchers brought the 6 water samples in Intertech testing services located in Makati City. The presence of mercury was identified through the use of the atomic absorption spectrophotometer. Forgetting the boiling point of the water samples. The water samples from each rivers were separately boiled using an earthenware flask, alcohol lamp, rubber stopper, tripod, and a thermometer to measure the specific temperature. It was done in 3 trials, and at the end, the average was computed. In getting the pH level of the water samples, the researchers used a pH meter to determine the acidity of the 3 water samples with an exact amount of 100 ml each. While in determining the density of the 3 water samples, the researchers used a digital weighing scale. The researchers weighed the 100 ml graduated cylinder first, then added the water sample, and in order to come up with the exact mass of each sample, they subtracted the mass of the water and graduated cylinder to the mass of graduated cylinder. To sum up, these methods helped the researchers in gathering the overall data. Finally, here's Therese Nicolas to present the summary of the study's findings, supported by the tables found in Chapter 4.
The summary of the findings shows the specific problems, which are correlated with the findings from the tables. Our first specific problem is how are the waters of Meycauayan, Marilao, and Bocaue rivers compared in terms of their physical properties, namely boiling point, pH level, and density. According to our findings, the boiling point of the said rivers are as follows: Meycauayan 93 degrees Celsius, Marilao 96 degrees Celsius, and Bocaue 95 degrees Celsius. Marilao River has the highest boiling point, while Meycauayan River has the lowest boiling point. The pH level of the said rivers are as follows: Meycauayan 6.9, Marilao 6.7, and Bocaue 6.0. And the density of the said rivers are as follows: Meycauayan and Marilao have the same density, which is 0.98 grams per cubic centimeter, and Bocaue has a density of 0.99 grams per cubic centimeter. Our second specific problem is, what are the properties of Cucurbita agricultural waste? According to our findings, the properties of Cucurbita agricultural waste are color, which is brown, state, which is in a solid state, and texture, which has a finely powdered texture. Our third specific problem is mercury present in the waters of Meycauayan, Marilao, and Bocaue rivers along MacArthur Highway? According to our findings, the said rivers have mercury content present in them, since all the 3 rivers have a mercury level of less than 0.001 milligrams per liter. Our fourth specific problem is which river has the highest and the lowest level of mercury? Since all the three rivers have a mercury level of less than 0.001 milligrams per liter, there is no river with the highest nor the lowest level of mercury. Our fifth specific problem is there a significant difference in the levels of mercury found in the waters of Meycauayan, Marilao, and Bocaue rivers before exposure to Cucurbita agricultural waste? The null hypothesis is accepted since the mercury level present in the three water samples from the said rivers are all the same. The null hypothesis states that there is no significant difference in the mercury content of the rivers of Meycauayan, Marilao, and Bocaue before exposure to Cucurbita agricultural waste. Our sixth specific problem is what happens to the level of mercury after exposure to Cucurbita agricultural waste. According to our findings, there is no significant change in the mercury levels of the waters of the three rivers after exposure to Cucurbita agricultural waste. Our seventh specific problem is there a significant difference in the levels of mercury found in the waters of Meycauayan, Marilao, and Bocaue rivers after exposure to Cucurbita agricultural waste? As I said before, the null hypothesis is accepted since the mercury level from the three water samples of the said rivers are all the same. The null hypothesis states that there is no significant difference in the mercury content of the rivers of Meycauayan, Marilao, and Bocaue after exposure to Cucurbita agricultural waste. Our eighth specific problem is how are the waters of Meycauayan, Marilao, and Bocaue rivers compared in terms of their mercury level contamination? The waters of the three rivers were compared in terms of their mercury level contamination, both before and after exposure to Cucurbita agricultural waste. All the three rivers had a mercury level of less than 0.001 milligram per liter, both before and after exposure to Cucurbita agricultural waste. Our last specific problem is Cucurbita agricultural waste effective in absorbing the mercury found in the waters of Meycauayan, Marilao, and Bocaue rivers? According to our findings, since the mercury levels of the said three rivers is the same both before and after exposure to Cucurbita agricultural waste, the 100 grams of Cucurbita agricultural waste did not absorb the mercury found in each of the 500 milliliter water samples from the said rivers. These are the specific problems and the findings per problem. And now, may I introduce Regina Agapito to explain the conclusions of the study, supported by the theories and literatures, and the recommendations of the group.
For the conclusion part, the first conclusion that the researchers came up with is that the waters of Meycauayan, Marilao, and Bocaue rivers were compared in terms of the properties, namely boiling point, pH level, and density, through which has the highest and lowest value or level. For the boiling point, according to the European Commission's article, the boiling point of mercury is generally high. However, there are some circumstances where mercury will have a lower boiling point than water because it tends to evaporate under normal ambient temperature. Therefore, water that contains mercury will likely have a lower boiling point. In terms of the pH level, a study by Delval, Foria, Para, and Riba states that heavy metals through water can influence the pH level, wherein when there is low pH level, there is a much greater toxicity from the water. Based on the results, Meycauayan has the highest pH level of 6.9, indicating that it is the less toxic, Marilao is the second highest with 6.7, indicating that it is more toxic than Meycauayan. And lastly, the Bocaue River having a pH of 6, which is the lowest, indicating that this is the most toxic or contaminated out of the three rivers. And now for the density. An article from Virtual Laboratory has shown that the presence of heavy metals can alter density, implying that higher density results to more presence of heavy metals. Bocaue River has the highest density of 0.99 gram per cubic centimeter, indicating that it has more presence of mercury, while Meycauayan and Marilao has equal densities of 0.98 gram per cubic centimeter, possibly indicating that they have less presence of mercury than the Bocaue River. The group also concluded that there is presence of mercury in the rivers of Meycauayan, Marilao, and Bocaue along MacArthur Highway. And for that reason, the group rejects the null hypothesis and accepts the alternative hypothesis. This corresponds with the Bethe theory and the theory of X-ray and neutron scattering for lignocellulosic biomass characterization, where the adsorption process happened as a study from Harmon, Patrick, and Spittler states that pumpkin waste primarily constitutes lignocellulosic materials, having it result to a promising effect in the absorption of heavy metals. Based from the results given by the Intertech testing services, the water samples of Meycauayan, Marilao, and Bocaue resulted to a mercury content of less than 0.001 mg per liter. Additionally, as the U.S. Environmental Agency stated that the maximum contaminant level and maximum contaminant level goal of water for mercury is 0.002 mg per liter, the water samples from Meycauayan, Marilao, and Bocaue rivers have no known or expected health risks. For the third conclusion, there is no significant difference on the mercury content of the rivers of Meycauayan, Marilao, and Bocaue before and after exposure to Cucurbita agricultural waste. Since there is no change in the mercury level of waters of Meycauayan, Marilao, and Bocaue rivers, which is less than 0.01 mg per liter for before and after exposure, the researchers reject the alternative hypothesis and accept the null hypothesis. According to the study of Kearney, Litvos, and Wilson, agricultural waste do not have the capacity to absorb heavy metals, but only some can be used depending on the structures and the adsorbent components that a specific agricultural waste may possess. Meanwhile, the final conclusion of the study states that the 100 grams of Cucurbita agricultural waste did not absorb the mercury found in the 500 milliliters of water sample from each of the rivers of Meycauayan, Marilao, and Bocaue after an exposure of 8 hours. According to the study of Tripathi and Ranjan, the utilization of untreated agricultural wastes as adsorbents may generate some problems, and so they need to be modified or treated first before being applied for the removal of heavy metals. Since the Cucurbita agricultural waste used for this study was not treated, it is deemed as not effective in absorbing the mercury found from the waters of Meycauayan, Marilao, and Bocaue rivers. Another study conducted by Sayed, Shady, and Tawab has shown that the length of exposure to agricultural waste may also cause the result of the absorption. They tested this by having one aquarium which had agricultural wastes and another aquarium which was agricultural waste free. This was conducted for 24 hours of exposure, where the concentration of heavy metals from agricultural waste containing aquarium was lower than the agricultural waste free. And now for the recommendations. Firstly, for the students, the study may be used to gain information on water contamination and heavy metals and to help them in being more mindful of the different pollutants which are detrimental to both the environment and human health. For the future researchers, they may conduct further study by lengthening the time of exposure to Cucurbita or other agricultural wastes and examine them with different chosen heavy metals. They may also increase the amount of Cucurbita to be used or treat and modify the Cucurbita or other agricultural wastes. They may also use this study to develop and innovate more effective agricultural wastes and test other non-contaminated bodies of water. For the community, they may benefit by acquiring knowledge on the effects of heavy metals to one's health and know the benefits of agricultural wastes in lessening water pollution or contamination. They may also use this to utilize other agricultural wastes as adsorbents of heavy metals which are detrimental at certain levels to the environment such as mercury. Lastly, for the local and national government who may coordinate with other organizations to conduct more studies and projects regarding water contamination and produce certain actions or laws in order to lessen this issue happening both locally and nationally. To now end the presentation of the group study, the researchers would like to instill an important message. Be a part of the solution, not the pollution. Thank you and God bless everyone.